All right, hello everybody. My name is Ria, and my co-host here is Alan, and we are both members of the FTC team 6165, the MSEC Cuttlefish. And in today's presentation, we're going to be talking to you all about how to use the CAD software Fusion360 and why and how you can use custom machining and manufacturing for your robots in this competition season. So Alan will get us kicked off with some introductions to CAD and Fusion360.
So as you already know, we're going to be focusing on CAD and custom manufacturing in this slideshow. This is just an introduction slide. As you see, that's me, Alan. Here's the picture of Ria, and that is a team picture from 2019 at regionals. So we're going to start off with just an introduction on what is CAD. What is CAD is an acronym for Computer Aided Design. It basically allows you to design custom parts and objects in specialized computer programs like Fusion360, Autodesk Inventor, or SolidWorks. And you can later manufacture these with custom manufacturing machines like 3D printers and laser cutters. And CAD basically makes your construction process a lot more efficient and streamlined because you can do things like adjusting dimensions and spacing before you actually build it, so you don't have to waste a lot of materials remaking the same piece over and over. And just a tip, we recommend using a mouse because a lot of the CAD movements and stuff need your mouse controls. So if you're going to follow along while we instruct, then you should use a mouse. So why use Fusion360? Well, first of all, it's free to students. It's really easy to get a student license for Autodesk. You just sign up on their educational website and send a picture of your photo ID, which is like your school ID, and within like 20 minutes, they'll get back on you on whether they accept it or reject it. Most of the time, if you send them like a valid school ID, they will accept it, and you have access to a lot of their products. It has cloud storage, which means all files are stored online, and also means that you can collaborate with their Teams feature, which is basically which allows you to collaborate with other people. All right, so we can get started with the demo now.
All right, so basically I'm just gonna spend the next about half an hour walking you guys through some of the most essential features in Fusion360, specifically when you're applying it towards CADing for an FTC robot. And so starting off, obviously to CAD in a software, you need to really understand how to control your own positioning in the software. And so like Alan mentioned, I'm actually using a mouse for this demo. We do recommend use a mouse specifically for these features and all this control stuff, but I will explain to you how you can use the software without using a mouse in case you just don't have one available to you or you can't get one. So the first things you should know, there's three basic types of movement. You can zoom, you can pan, and you can rotate, or in Fusion360, it's actually called orbiting. So to zoom in and out of your screen, you use the center little mouse thing here, and you can just zoom in and out. To pan the screen, you actually hold this down, click it, and then you just drag your mouse and it'll pan the screen in a linear format. And then to rotate, you hold down the shift key on your keyboard and click that middle mouse button again, and it'll orbit around the screen. So now that we know that control system, basically the way you design a model in CAD is you start off with a two-dimensional drawing, right? And so this two-dimensional drawing serves almost like a cross-section of what you're actually going to be creating. And you create this two-dimensional drawing, and then you add a third dimension to it. In other words, you add some kind of depth to it, and that allows you to create a three-dimensional object. So to create that two-dimensional drawing I was talking about, you have to create what's called a sketch. And so up in this top, you see Create Sketch. And now you can see we have these three basic planes available to us, right? The X, Y, and Z plane. So for this demonstration, I'm just going to start off on this plane. It doesn't really matter which one you choose. But as you can see, when it opens up, now we're working with a two-dimensional space. And so this is where you can make all your drawings. If you ever drawn a graph on graph paper, it's pretty much the same experience, except now you're actually making shapes. And so the basis of what you're going to be designing with a sketch is going to be from this Create toolbar up here. So as you can see, there's a lot of different options. These are kind of the most common ones, which is why they short key it. And I'm not going to be able to go through all of these just because we don't have that much time. But I'm going to go through some of the ones that I have used the most and that I have found to be the most essential for CADing parts for your robot. So obviously with the line tool, it's pretty intuitive. When you click on it, you can basically identify 2 points. It creates a line between those 2 points. Now rectangle is probably one of the most commonly used sketch tools, and this is all called sketch geometry, by the way. So if you hear me referring to sketch geometry, it's basically the geometry that you are using in a sketch. And so to create a rectangle, the most common type of rectangle or the most common way to create a type of rectangle is by this 2-point rectangle toggled by the short key R. And so the 2-point rectangle, you essentially just click on 2 corners that you want your rectangle to have. And so if I click, let's say here, and then I click here, I've identified my 2 opposing corners, and now I have a rectangle. You can see that it's a closed off shape because the whole thing is highlighted in this light blue. And to escape this, obviously, maybe I don't want to create another rectangle, which is what it's kind of prompting me to do, as you can tell by the little rectangle next to my cursor. I just click the escape key, it exits me out of that tool. Let's just go through a couple more of these basic sketch geometry. So the next one's a circle. The most common one, the way to create it is the center diameter circle. And to do this, you basically just click where you want the center of your circle to be. Say I do it here. And then you identify what you want the diameter to be. So currently it says 40 millimeters, that's my diameter. I'll show you guys how to change the dimensions once you've clicked it in just a moment. Some of the other really commonly used sketch geometry, we have an arc. And so there's 2 really common ways to create an arc out of these 3. One of them is the 3-point arc, one of them is this tangent arc. I'll show you guys both. So 3-point arc, you choose the start point, the end point, and then you choose some kind of radius here. So let's say I want to make it look like this. Now with a tangent arc, you just choose 2 points and it creates an arc out of that. So if I click here and then I click here, you can see it's just designed the arc around that. So that's 2 different ways you can create an arc here. Some of the other really commonly used sketch geometry, we have a polygon. So there are obviously 3 ways to create a polygon. With circumscribed, you are defining the center of the polygon and then the midpoint of one of the sides. If you've studied geometry, this is known as a circumscribed polygon. The next one, which is called inscribed polygon, is where you're going to define the center of the polygon and one of the vertices. And then the last one, you're going to define the length of one of the edges, and then you specify the number of sides for all of these. With an ellipse, you choose the center point, and then essentially the farthest point in one direction and the farthest point in the other, otherwise known as you define the major and the minor axis. And as you can tell, every time I highlight over one of these tools, it gives me an explanation of the tool. So if you can't remember everything from today, it's totally okay. You can go back and consult with the software. Now a slot seems like a kind of strange thing that I would be calling an essential tool, but when it comes to actually building parts for your robot, a slot is going to be really, really helpful, because a lot of the time when you're building, even if you're fully CADing your entire robot, you may still not know for like 100% certainty where you need maybe a certain screw hole to go to mount a part onto your robot. And so by using a slot, because a slot essentially has a diameter, right? It has its actual height, but then it can have a really long length. And so if you put a screw into a slot and you tighten it, the screw isn't actually going to move very much. And so that's where a slot comes in really handy, is you can create a slot instead of a hole if you're putting a screw through, and that'll give you a little bit more flexibility and a little bit more room to adjust wherever your part is being mounted once you are creating the part and once you've manufactured it. A spline creates a smooth line through some defined points that you create. It's not used super often, but I have seen some people use it for various purposes. Conic curves aren't used often at all. And then we have points. Points are used generally as a way to reference other geometry to the point. And so obviously you know what a point is, but the reason you would use it in your CAD is because if you're, let's say, creating a polygon, you might want to define a certain point, like a point to be at a certain location, so that your polygon can be created around that point. And then obviously we have text. Text is used mostly for an aesthetic purpose. I would say the most common usage in FTC is because we are required to have something on the opposing sides of our robot that have our team number on them. And for a lot of teams, instead of maybe taping something on or like writing something on a piece of paper, they choose to actually manufacture a part that just has their team number on it that they can stick on. And so it's a really fun tool to play with when you're going for that kind of aesthetic. Now, these 4 things, we have these 3 up here in the sketch dimension, are all ways to essentially manipulate and control the actual sketch geometry you've created. And so mirror allows you to do exactly what it sounds like. You define an axis and it mirrors whatever sketch you choose over that axis. So let me demonstrate that real quick. So let's say I create a line right down the center over here, right? And let's say my intention with creating this line is that I can mirror the circle over the line to get one on the other side. So the first thing you might have noticed is when I created this line, now my sketch has been divided into these 2 separate areas. But because I'm only using this line to mirror the circle, that's not really what I'm going for. So if I right click on the line here, you'll see it gives me this option, normal/construction. And if I click it, the line becomes dashed and the rectangle's whole again. And so this is what's called construction geometry. And so this is something that you draw into your sketch, but it's used purely as like a frame of reference or a way to, essentially a means to an end for constructing other geometry. And so now if I go to the mirror tool, you see it prompts me to choose an object. I'm going to choose the circle. Then it prompts me to choose the mirror line. So I'm going to choose this dashed line I just created, click OK. And now I have circles on both sides of this. And something that we're going to take a look at in just a second is actually how, because I use the mirror tool to create these, there is now an axis of symmetry right here for these two objects. So if I change the dimensions or the positioning of this object, it'll change this one. Again, I'll show that to you guys in just a second. Now, these two patterning tools, right? Basically what these create is it's a way to take a sketch you've already drawn or part of a sketch you've already drawn and replicate it in a certain pattern, as it might be implied. So a circular pattern, you can replicate things in a circular form. And now, why is this useful? Well, if you guys have ever looked at a standard FTC motor, you'll see that on the top of the motor, where you can actually screw the motor into something to mount it, it is a circular pattern of screws. And there are two ways you could create a circular pattern of holes in this case, so that you can mount something like a motor to it, your part. And one of them is you manually measure everything, where you measure the distance between all the circles, you make sure you get all the angles correct if it's, you know, like 6 circles in a circle or 6 holes in a circle. The other way is you actually use a circular pattern. And so I'll show it to you in just real quick. The object, let's say I want to take this circle this time. Now I choose a center point, let's say it was this, and you can see that it's actually creating a pattern of circles around that point with the object I highlighted. And so this is a really accurate and precise way of getting that kind of circular patterning. And this will be really useful for creating different types of mounting structure. Now the second type of pattern is rectangular. This is a lot more intuitive. It actually just creates a grid of whatever you're trying to design. And so if I create a rectangular pattern with this, you see there's a lot more options I have to work with, and that's because I can actually define the distance between all my objects and how many of them I want. So I could keep increasing this number and increasing where the last one's going to land. The last thing I want to talk about in this dropdown is sketch dimensioning. This is probably one of the most important parts of CADing. In fact, in my opinion, it is the most important part. And that is because when you're creating a CAD model, you're trying to design a custom part, the most important part of making that custom part is making sure that all the dimensions are exactly as you need it to be for it to serve your robot, right? Because there's no point in creating a custom part if you're just going to put in random numbers, because it's not actually going to fulfill any need that you have. And there are many different things that the sketch dimension tool can do. So I'll show it to you just right now. It can define a basic distance, right? Maybe 200 millimeters is where I want this to be. But now I can actually double click this. And if I change it to 250, it will expand the rectangle. So now the actual length here is 250 millimeters. It can also do the radius of a circle. So instead of 40, it's going to make this 50, or sorry, this diameter. So now the diameter is 50 millimeters. It can also do the distance between two objects. So when I was showing you that things are getting mirrored, you can see it here. You can also see that if I make the distance between the center point and this axis over here, maybe 75 millimeters, then you'll see that this and this are actually the same distance still. And so that's kind of the 3 basic uses of sketch dimensioning. Now let's go to this modify tab over here. So there are a couple things here that are really, really crucial. The first one's called fillet. And what this does is it rounds out your corner on some radius that you define. So you can see here that I am allowed to choose what radius I want to work with. Say I make it 20 millimeters. And now the radius of this essentially arc is 20 millimeters. And I'll get more into this when we get to actually creating our 3D objects, not just these sketches. But the reason you want to use fillets, besides the whole like aesthetic value of having something looks more rounded, is actually because there is a rule in your robot inspection manual that will say that you cannot have sharp edges on your robot. And obviously we're working with a lot of metal, working with a lot of hard plastics. This might seem like something you can't avoid, but it's really important to either file down your metal or to create these kind of rounded edges, because it is a huge safety hazard to have sharp metal on your robot. And so this is where a lot of teams will use this fillet feature here and into the 3D section because they want to avoid even having to manufacture these sharp edges. So that's a fillet tool. Now we're going to move on to what's called the trim tool. So you might see that this semicircle and this rest part of my design are both separate entities because I can highlight them separately. But let's say I want these to all be one thing. I don't want these to all be separated, right? Or at least I don't want these to be separated for this purpose. So if I click this trim tool, I can actually just cut that line out. And now when I select the entire thing, it's one big part. And so trimming is really useful when you know that, well, I'll get to it later, but when we are extruding and revolving and working with creating that third dimension of depth with different parts, if you know that you want all of this stuff to work together, you don't want that semicircle to be operating independently, you just trim out that line and it becomes so much easier to work with all of that. Now, there's obviously more tools here. I'll just quickly rattle off what the rest of these do. So the extend feature extends some geometry to a line or a defined boundary. The break feature does the opposite of what I just tried to accomplish with the trim feature, where instead of getting rid of a line to combine these two parts, it actually allows you to define where you want a continuous line to cut off and create different segments. The sketch scale function allows you to scale up or down your object, and then offset, I'll show it to you guys right now, allows you to actually create an offset geometry like this. And so if I define this to be -10 millimeters, now I have this thing split where I have a rim here and then I have the inside here. All right, so the last thing you want to do is talk a little bit more about this dimensioning. So when I talked about dimensioning, right, I was talking about how to create these numeric quantities that can define the sketches and everything that's in these objects. But there are more ways to define things than just these dimensions, right? Let's say I'm working at a computer right now, and I can say that, oh, I am, a foot away from this computer. But if I'm actually typing on it, I can also say, instead of saying that I'm like 0 millimeters away from the computer, I can also say that I am touching the computer, something similar to that, right? And there's also a way to model that in CAD software. So instead of having to give everything a numeric value, you can also give things relative positioning. And so that's what's called constraints. So constraints are different ways to define the position of an object relative to another. And I'll just rattle off all of these. So horizontal and vertical is pretty intuitive. It defines a horizontal or vertical line. One thing to know is this is usually automatically applied to your designs if you draw in a horizontal or vertical line, especially because Fusion360 allows you to kind of grid snap everything. Coincident takes 2 points and merges them into kind of 1 point. So if you have a line here and a line here, and you make these top 2 points coincident, they will meet together. And since I was talking about how you want your shapes to all be closed off, you want this light blue color, if you're not seeing that, it's possible that the points you have defined are not meeting together, so it's not actually closed. Coincident solves that problem. Tangent establishes a tangent relationship where two objects are only touching at 1 point. Equal, if you have worked with vectors before, it essentially makes 2 lines or 2 circles the exact same size and also point in the exact same direction. So if you have 2 lines that look like this, maybe this one's shorter, equal would basically just make them both look like this.
Tangent is what it sounds like. If you want a line to only contact like a circle at 1 point, then of course you use the tangent tool. Equal would just make the two whatever objects you select equal. So suppose you have 2 circles and then you want to set both of them to 10 millimeters in diameter. Instead of manually going through and smart dimensioning it with 10 millimeters each, you can just set one as 10 millimeters and then set the other one as equal to it, and you would have those would be equal. Parallel is just having the lines be parallel. Parallel and perpendicular, I think, are pretty self-explanatory. Fixing an object. Suppose you want to lock the relative position of an object. You would use the fix. Midpoint is putting a midpoint. It's pretty self-explanatory. Concentric is if you want 2 circles to be around the same midpoint, then use concentric. Collinear is on the same line. So if you want 2 lines to share, or like 2 different lines to share one line, then you'd use collinear. Symmetry is like mirroring, and curvature is making a curve.
So let's take a look back at our old design over here. So obviously Alan just explained all the constraints. Now, one thing I do want to show all of you is actually sort of the power of this fix unfix and the whole idea of fixing your dimensions. So as Alan mentioned, when you fix the dimension of something, essentially what you're doing is you're locking that position and all the dimensions associated. So if I click this, you'll see it turned green. That means that I've manually fixed the object. Now, there's one other thing that I could do, which is if I fix an object and there are essentially so many relative positions based off that object that affect another object. And so the other object becomes fixed as a result. And that might not be happening right now, but there are times that objects will become fixed like that, and that it will cause it to be outlined in like this kind of black color, like it is when I'm highlighting it. And so essentially your goal when you're sketching something and you're dimensioning and putting all these constraints in is to make everything have this kind of black outline border. In fact, let me see if I can just quickly get that. Anyways, I'll show it to you at a later time, but essentially you want everything to be outlined in black. That is sort of the ideal. For now, because of time, I'm going to not like worry about that. The last thing with sketching is you want to be able to measure things. And so a lot of the time when you're working with CADing for FTC, you actually download parts off the internet that maybe are like store-bought parts like motors or slides, and you need to be able to measure them in order to either create a custom part for it or just to build something in person. And so by using this measure tool, you can just click on different lines, and at the bottom here, it tells me what the length of it is. It can also do the radius of a circle, and it can also do the area of something. And so this measure tool becomes really helpful, especially when you're working with CAD files that you did not create in Dimension. So let's say that this was all ready to go. This is the sketch I wanted. I can click Finish Sketch here, and we're back in our 3D plane with this sketch on the ground here. Now, we talked about adding depth to the sketch. That's what we're going to do right now. So there's multiple different ways to do that. We have our Create tool back with all these different options. And this might seem overwhelming, but a lot of these are not super necessary, especially for FTC. And so I'm just going to talk through the ones that I found to be the most useful. The first one's the Extrude. This is your most fundamental way of adding depth to an object. So if I just click on, let's say this, and enter a number like 5, now this has become 5 millimeters tall. One other thing to know is when you're working with Extrude, once you've extruded an object, the sketch that you're working with actually disappears. So you can get that to reappear by clicking here. Also with extruding, you can click on multiple objects and extrude them all at the same time. So let's say I click on this as well, I click on this as well. I click 5, now all these have been extruded and they've all kind of merged together into the same part. There's another way to do this, to work with making something three-dimensional, and that is with this revolve feature. So if you guys have ever seen the handle of something that kind of looks smooth and curved, that's almost like you revolve a circle around some kind of center point and then it becomes like that, if you think about it that way. And that's exactly what we're going to do right now. So you see on the bottom of the sketch here, I still have my little axis here. I have a circle here I could work with. So if I just choose an axis, let's say I make it this point right here, which is the one I'd drawn in as construction geometry. And now I have this option to choose the number of degrees I want this to be. The other thing to note here is this whole thing's outlined in red. That might seem kind of strange because like red's bad, right? Red's bad. Red in this case is kind of like implying that same thing because the operation defined here is cut. So cut is going to cut into the object. This is also available in the extrude panel. But because I want this to be kind of like a handle, I actually want to do join. And so that'll join it with the current existing body. I'm also going to choose to do this as 180 degrees instead of 360. And I'm going to flip this around, and you can see that now we have this handle that's going 180 degrees. All right, so the next tool is called the hole tool. This one is not used super often because basically what this hole tool does is it actually creates a threaded hole, so holes that you can screw screws into. And when you're manufacturing a part, you generally don't want to do this just because the structural integrity of like a nut for a screw is going to be a lot better than these kind of plastic materials. But if you do choose to use this, let's say I select, I don't know, this whole face here, and now I have a hole I could throw in, you see that there's all these options to define the thread of the hole. If you are working with putting screws through an object, my recommendation is to actually use the extrude panel And then let's say I chose the circle again. I'm actually going to do a cut feature on the extrude. And that will allow me, if I just drag this out. Now, theoretically, if I had a really massive screw, I could put it through here and put a nut on the other side. And as we talked about with the sketching, the mirror feature is also available here. We also have the rectangular and circular patterns available here. Patterning on path is not super necessary to know right off the bat. All right, so we've gone through this create tab. Now there's a couple things on this modify tab that I want to talk through. So one of them is called, again, the fillet. As I talked about, you can also fillet with three-dimensional objects, and I'll show you all how to do that. So if I select this edge, let's say, and maybe I'll also do this one, I can now define a radius upon which I want this to be smoothed out. And so as you can see, it's a lot smoother now. If I were cutting this exactly or manufacturing this exactly as it looks, I wouldn't have that sharp edge to deal with. There's also another kind of thing you can play around with that is not quite a fillet, but it operates similarly. It's called a chamfer. And so I put that here on the bottom. Essentially what a chamfer does is it creates an what a chamfer would do is it creates an angle, like almost like a triangle or an angled cut on the top of the object so that, if you look here, so that it's also not as sharp. And so if I look from the side, you can see that it's kind of angled downwards now. And so it looks pretty cool. It also serves an actual practical purpose. And so there are also, again, a lot more things here. You can look through these, highlight them to figure out what they do, but these are generally not going to be as widely used. All right, so that's pretty much how you create a part. Now, obviously, when you're working with a robot, there are a ton of different parts on the same surface. And so you want to figure out how to work with multiple parts. And that's what's called an assembly. It's an assembly of different parts. Let's say that for my assembly here, I wanted to mount this object on top of like a rectangular prism. So what I can do is I can create a new part. In fact, let me actually show you guys something first. So maybe I want to create a new part, right? But if I want this new part to be, let's say, right underneath this object, it might not be ideal for me to create it on the same plane here. And so in this construction geometry panel, I can choose a whole bunch of different options. For now, I'm just going to go with the offset plane. And you can manipulate this as you want. Because I am doing it underneath and this was on a plane, I don't quite need to do this, but you can still look into this. It's actually quite a fun thing to play with and very practical. I'll show more about that in just a second. But let's create a new sketch right here on the bottom. And I can define my plane. If this was not actually on the plane and I clicked on a flat face, I could also create a sketch off of that. So that's pretty cool. So let's say I'm actually going to do this offset just so I can show you all something in a second. But here's a rectangle. Very nice. And now let me extrude it in this downwards direction, 20 millimeters. Okay, so I have these two objects. I wanted this to be on top of this though. One thing I could do is I could kind of just drag this around if I wanted to, but that's not actually going to get me a very precise measurement, right? So instead, I'm going to work with our assembly. And so currently, if you look in this bodies tab, we have two bodies. One of them is our original part. One of them is this rectangular prism. And to work with an assembly, you need what's called a component, not a body. And so I need to convert these bodies to components. The way I can do that is I click this new component button, click from bodies because the body already exists, select this, click OK. You'll see that it's gone from the bodies tab, but now I have component 1:1. I can do the same thing to my prism, and now I have two components and no bodies tab at all. And that means that all of these are now independent entities that are not going to be quite manipulated into changing the actual object, but they can be used for assemblies. All right, so now what I want to do is get this on top of this. So I'm going to use this joint feature. And what this joint feature does is it allows you to create relationships between different components. And so if I select this, and let's say I select this as well, looked a little jank, but essentially what it's doing is it's lining them up, so now they're next to each other. And now I can actually move this and establish a defined offset where this is now a certain number of millimeters away from where it was originally positioned. But click OK. You hide the sketch. You'll see that these are now moving around together. And so that is the basics of creating an assembly in Fusion. Now I talked about the construction geometry. I'm just going to quickly rattle through this one more time. But there are a whole bunch of different ways you can define planes, axes, and points in your Fusion 360 model so that you can create more sketches and have more relationships between objects. So the most commonly used one is offset plane. I'm just going to demonstrate that one, but you can experiment with the other ones on your own time. So if I want to maybe do an offset plane from, let's say the top of this, right? I want it to be 50 millimeters higher so that it's kind of cutting into the top of my little torus here. So now I have this plane here, which allows me to actually create a sketch right there on top of the object. So if you look from here, you'll see this plane is no longer on my basic XYZ. I've actually created my own plane. And the one really helpful thing when you're working with an offset plane or some kind of object like this is this tool called project. And so what this does is it takes the imprint of this object I've already created, and now in this purple outline, you can see it's been sort of highlighted on my new plane. And so if I'm trying to create an object that maybe has some kind of relationship to the object below it, or that's going to intersect that, I can actually have this as like a frame of reference, and I can use it as part of my constraints or as a reference point construction geometry for my sketch. So now let's say this is my final part, right? I have my little strange looking object here, and I want to actually, let's say 3D print this, right? First, I'm going to go ahead and save this. So this is 3D print part. I'm going to put this in my folder. As you can see, this is not my like desktop save folder because this is being saved in the Fusion 360 cloud. In other words, it's being saved to my account, not to my laptop. And so I saved this right here. So it's saved. And now what I can do is I can export the part. And there are a whole bunch of different file formats to export. And since we're going to talk about manufacturing this presentation just a little bit, I'm just going to quickly go through some of them. So these are both your standard save files. If you have a Fusion file, Inventor is also an Autodesk product. If you've heard of an Autodesk Inventor, you can also save as an Inventor part file. DWG and DXF are called draw files. These are like two-dimensional sketch files. So you won't be able to export a 3D printed part. You'll choose a face of the part that you want to turn into a sketch, and you can save that. OBJ and STL are both 3D model files. You would plug those into like a 3D printer software that slices it all up. But essentially, this is your export format if you want to 3D print something. And a step file is a really universal file format that works in every single type of CAD software. You can import it into all different reader formats, and you can really easily convert a step file into different other types of files. But since I'm going to 3D print this file, I'm going to create it as an STL. You can see that it's actually going to save locally to my laptop. And so if I click export, it starts that process right here. And so once you have an STL or any kind of one of these export formats, what can you really do with it? Well, that's all manufacturing. So Alan will talk to y'all about that right now.
All right, so the first thing we're going to talk about is what exactly is custom manufacturing. So custom manufacturing is basically physically creating the part that is based around the specifications in your CAD. So it will create the part with the dimensions you specify in your CAD and allows you to create what you want, your ideal design, without much material wastage. Of course, as you get better, well, when you first start out at CADing, of course, you're going to waste some material because you're not that experienced, and getting the design spot on your first try is going to be hard. But as you get better, you will start having less and less iterations on your CAD. And custom manufacturing will require your CAD software, and of course, you're going to need the machines for it. So first off, we're going to talk about one very common sort of custom manufacturing, which is 3D printers. So basically, all of you should be pretty familiar with this. It just prints objects by melting different types of plastics. It stacks different layers of melted plastic on top of each other to create different kinds of shapes. So it's very helpful for creating custom parts that need to be created as one piece, and you can't convert to something 2D in order to cut on a laser cutter or something like that. The only potential downside of this is that it does take a while to print, as it takes time for it to stack up the layers of thin plastic, and the material costs can rise as the plastic can be kind of expensive. As Ria mentioned, the most common file type for this is a STL, but some 3D printers might need you to convert to some other file type for their unique program. Next is a laser cutter. So laser cutter uses, of course, as its name implies, a laser to cut out 2D objects on different materials like acrylic, MDF, even different kinds of wood, and even some kinds of specialized metal like some specialized aluminum. So the files for this needs to be in a vector format, which is, like we said, a DXF or a DWG, because the laser cutter reads those vectors and it translates that to the path it takes. And of course, the pro about using a laser cutter is that it's really fast. You can import a file, and then in a few minutes you can have your part ready. So if you want to prototype really fast, a laser cutter is probably your best bet, but it is expensive to get a laser cutter. And the third one is going to be CNC machines. CNC machines basically use a drill bit to carve out shapes and materials like metal. If you want to cut something out of metal, out of like steel or like aluminum, CNC machine is probably your best bet. It will take some time to cut because, again, it is carving out layers on your material, but to make custom metal parts, it is probably needed. And of course, to use a CNC machine, you're going to have to learn how to cam, as that is how the program reads. The machine reads and converts it to the part. So also another very useful tool is called GrabCat. So if you're using Fusion 360, it might not be needed because Fusion 360 has an integrated team system that allows you to collaborate with other people. But if you're using another software, GrabCat is a really good software to use. It's basically GitHub for CAD. So it's cloud-based CAD collaboration. Basically, it means it will automatically detect if you changed or you added files to the specified file path, and it will automatically tell you to upload or download. So if someone else on the project downloads or uploads something and changes the part, it will tell you to download that. And if you change something, it will tell you to upload that. It's really easy to use. There's about 2 buttons you have to click. Right here is the UI. It's upload and download. So custom manufacturing is so powerful for robotics. It allows you to create unique parts that you yourself had designed to meet specific requirements or to fill a specific niche on your robot, and allows you to do things that standardized parts can't really do, and it greatly expands like the amount of things you can accomplish in robotics. Okay, so right now we're going to open up the floor to questions.
You can feel free to either ask your question out loud or send it to one of us in the chat feature. All right, so one question is, would you recommend Fusion for someone who is new to CADing? I think I would say I would definitely recommend Fusion. There are many advantages I think that Fusion has to a lot of other CAD softwares. The biggest one being that it is a free software for students. And so you're really not making any kind of commitment or obligation to paying for really expensive software if you end up not really wanting or needing to use it. In addition, it's like I showed you guys, it's actually pretty simple to use. You can do so many different things, right? There are a lot of things I didn't cover because they're just much more complex than we needed to for today. But there's a lot of power in this software for sort of the ease of use that it has. And so I would definitely recommend that if you are new to CADing, check out Fusion, try it out. There are some tutorials online if you maybe forget something that we covered today. And I mean, if you love using Fusion, there are more complex softwares you can go to, but I've also seen a lot of, especially robotics teams, that just stay on Fusion forever, and they end up making really, really amazing robots. So the next question is, what are some materials that you can print with, and are there any restrictions on those materials when you're working in FTC?
So for 3D printing, the main restriction for what you print is going to be the hose on it or the nozzle. Because that is the part that's actually melting the plastic. So if you're gonna print something that is more high tech, like carbon fiber, you're gonna need like a better nozzle, which you need to buy. But the most common types is like PLA, which is it's pretty cheap. So most things are gonna be made, most of your things that are gonna be made out of PLA, because if you're 3D printing, most of the times it's not gonna be under that much stress. So you don't need some like high tech material like carbon fiber, and also the 3D printing software allows you to check how dense dense you want it. You can be like, it can be 25% fill or 100% fill. Of course, it's going to take longer if you choose a more fill, but it will make it stronger. So most of the time, PLA is going to be your best bet.
Next question is, where can you get access to CNC machines? So CNC machines, obviously, they're pretty big, they're pretty expensive machines. It can be hard to get access to them. I would say that if whatever school or organization you're affiliated with has any kind of makerspace or anything, you can definitely reach out to them. For us, MSET, we're actually hosted by our local high school, and they have an engineering department that has a CNC machine that we're allowed to sort of use and borrow sometimes. If you don't have those kind of resources, there are also some programs online that you can look up where people can actually CNC the part and ship it to you. The reason why that's generally less preferable is just because there is kind of an incurred cost when you're asking someone else to machine the part for you. Sort of the final solution I'd give you is that since CNC machines and laser cutters both sort of take these 2D design files and create parts, a lot of the time you don't actually need to use a CNC machine. You can just use a laser cutter or something similar instead. A really hard acrylic is not only going to be a lot cheaper and easier to manufacture, but it's almost going to be as durable as using some kind of aluminum. And so if you aren't able to get access to CNC machines, definitely look into laser cutting and see if you can get most of your parts through that. The next question is, what's the most, oh, sorry.
Oh yeah, okay. I also add there's some like companies that will CNC stuff for you, but it's not recommended because it is generally very expensive.
Yeah. So the next question is, what's the most complex part you have manufactured during the FTC season? So for those of you who might have been in, played the competition game last year, you might remember that there's this thing called the capstone. Essentially what the purpose of that was you had this whole stack of just oversized Lego blocks, and you had to put an object on top of it to claim a huge point bonus. And the object that you put on top had to be custom made by your team and have like your team number on it. There are a bunch of sizing restrictions. And obviously you're putting it on top of these big Lego blocks. You do want to sort of conform it to that shape. And so it wasn't necessarily the most complex looking part, but I would definitely say it was one of the most difficult and most prototype parts that our team created. And it was just because the most complex parts are going to be the ones that have the most restrictions placed on them when you design them. So for this part, we had to not only have our team number on there at a certain size and then a certain number of places, we had to have a minimum size and a maximum size. It had to be able to fit in our robot in the modules it already had, but it also had to be able to stack on top of these brick looking things. And so that was definitely the most complex part that we designed. In terms of complex part that maybe wasn't as practical, we have made some more aesthetic looking parts. They're called side plates. Essentially, on the sides of your robot, you need to have your team number displayed. And so a lot of teams will actually have that as their most complicated looking part because they really like to increase the aesthetic of their robot by having these plates not just have their team number, but fancy decorations, all these fonts and things. And we sort of did that too. So I would say that that was the most complex part, and we also iterated that a lot. So are there any pre-CADed parts that you can use when you're CADing in your FTC robot? So for Alan, I assume that means that parts that you might be downloading.
Yeah, so if you're buying a lot of the websites that you're going to be buying from for like motors and stuff like that, or like pre-constructed parts, will have the CAD model. So all you have to do is probably go to the website, and usually on the like product page, if you scroll down a bit, they will have CAD models like just listed there for download.
Yeah, in fact, I can just show that right now. So you can all see my Chrome window here. Basically, here's a Neverest motor. This is just a type of motor that you can get from the site called AndyMark. If I scroll all the way down all these technical specifications, you'll see documents. And here I can get the CAD file for the document. So when I was talking about the universal use of a step file, this is kind of where it is, where if I download the step file, I could just open it up in Fusion or whatever other software I'm using and then manipulate that part. The next question is about how many parts should a rookie team custom make for their robot? So
I think it ultimately comes down to, of course, if you have the machining tools for it and how comfortable you are with CAD. If you're pretty comfortable, like veteran teams are, they usually custom CAD the whole robot. But as a rookie team, if you aren't that comfortable with CAD, then I think using standardized parts is probably easier. And even if you use standardized parts, if you want to get more familiar with CAD, you can even grab the standardized part files off of the website, and you can CAD your robot in a software, even if you're using not custom parts.
Yeah, no,
Also,
definitely say,
yeah.
oh, sorry.
Oh, no, you can go.
I was just gonna say, I would definitely say that if you are a rookie team and you want to get experience of CAD, but you're also working with standardized parts, if you CAD your robot, it actually makes it a lot faster to not only build the robot afterwards, but also to fix things if they break down and the person who maybe kind of understood the design the best isn't able to be there. Because if you have this design up on like your laptop screen, it becomes very, very easy to see how parts fit into each other, make sure everything's going to work. And then instead of building things off of an image in your head, you actually have all the parts laid out in front of you. Alan, were you going to say anything?
I'd say if you really need to CAD something, it will probably be for like a very specific usage.
Yeah. All right. So the next question is, it's a really interesting question. So have you ever printed game elements for practicing if you don't have when you don't have access to the ones that you bought? I'll definitely say our team has not, and that's just because our game elements are pretty big and the material cost on that is going to be really high if you do end up printing those. If that becomes an issue, especially because we're all remote, where you need to kind of improvise game elements, I would recommend using parts like cardboard and tape and zip ties and whatnot instead of custom manufacturing the entire thing, just because you do want to avoid that material cost. But I will also say, since we're talking about game elements, the game elements CAD files are usually available online. And so you can usually pull those, and even if you build it out of cardboard or you're just using it as a reference point, it can be really helpful to have those CAD files on hand as well.
The thing with printing CAD out, with like printing game elements, is that also like some of them aren't made with like the specific material you can print with. Like this year, the rings, they are hard foam, I believe. And they're squishy. So if you print that, you're not going to get the same shooting consistency as if you had the actual game element, because you're shooting a different, the material is different. So the physics acting on it, of course, will be different.
All right, are there any more questions? How hard is it to use each custom manufacturing machine, and which ones are the easiest to learn? I'll say that the order that we gave them in, so 3D printing, then laser cutting, then CNCing, is probably the order I would say. I think 3D printing and laser cutting are both very easy to learn how to use. So for 3D printers, essentially you have to buy you have to download what's called a slicer software. There are a whole bunch of free ones available on the internet, but they take an STL file and they convert it to what's called G-code. And essentially, if you put G-code on an SD card, plug it into a printer, it'll just know exactly what to do. Basically, G-code just translates your file into instructions for the printer. For laser cutting, you actually have to convert to a PDF, because the way the laser cutter reads the file is by seeing the colors of different lines, where if it sees a red line, it knows to cut it all the way through. Sees a blue line, it knows to just sort of carve it, but not cut it all the way. If it sees a black line, it knows to kind of shade something in by just burning off the top layer. And so you can download a whole bunch of different softwares for that as well. For 3D printer software, I recommend what's called Ultimaker Cura. It's created by a 3D printer company, but it's pretty universal. And then for laser cutters, I recommend what's called CorelDRAW. And both of those are super easy to learn. The machines are generally, since they've been tested so often with people using them for so long, they're generally pretty safe. I do recommend talking to an adult who does know how to use them beforehand. For CNCing, I would say that's definitely the hardest one to pick up and use, which is why a lot of teams don't choose to use it, just because you do need to learn this entire process called camming, which is incredibly complicated and requires usually like a separate software. It's actually easier to integrate with Fusion than other software, surprisingly. And then also the machine can be pretty dangerous to operate. So hopefully that answers your question. All right, if there are no more questions, Alan, you can bring back up the contact page for us. If you have any questions throughout the season about either this presentation or just anything about FTC in general, you can totally feel free to reach out to us. These are all of our like social media handles. So at MSET6165, that's our Instagram. Then we have our email, our website, and our YouTube channel. Feel free to send us a question through any of these means, and we'll get back to you. We can help you out through the season on anything. Otherwise, thank you guys so much for coming. We're sorry about all like the technical issues in the middle. Hopefully you're able to learn a little bit more about CAD, Fusion 360, and manufacturing. And I hope you all have a great FTC season.